Saxon Algebra 2, Lesson 76. This is a gem, you guys. This lesson's fun and it'll make you feel really smart. What we're going to do is we're going to solve a system of equations using both substitution and elimination. What? I know, right? How cool is this going to be? You've been waiting all your life for this, and you know what's amazing? You didn't even know it. You didn't even know what there was to look forward to. Life is quite a bit like that. Example 76.1. Let me just show you. Because you're going to look at this and go, no, I cannot possibly do this. It's too hard. I've reached my capacity in algebra. I no longer will be able to learn anything new. My mind is blown. And then I'll teach you how to do it. And you'll be like, oh, that's actually really easy. And I'm looking forward to that moment. Remember that this is my idea of how to write a Z. Okay, this is a system. Notice that we have 3 equations, but we also have 3 variables. So that's fine, that's gonna work out. You need to have as many equations as you do variables. So 3 equations, 3 variables, we're good. Now, we know that in order to solve this system of equations, which means to find x equals y equals z equals, we have to use all 3 equations at one time or another, right? But how we use them is very much up to us. So what we want to do is look at this and take the easy way, right? I have no need to make algebra harder than it already is. So what catches my eye is look at this cute little bite-sized one. That looks really easy to deal with and super simple to substitute this 2y in for these x's, right? There's no coefficients or anything. We can just plop that in there, and then we'll be down to 2 equations, and we'll get rid of the x's, and we'll just have a y and a z. I love it, right? So that's step 1, is we're going to substitute. And I'm going to add to that, substitute what looks easy. Okay, that's the hint in these is go for what is going to be straightforward. So I love how little this is, and I just want to drop that in. And so I'm going to have 2y here. So in the first one, it's going to become 2y plus z equals 9. And then in the third one here, I'm just going to call these A, B, and C. So this is going to be my new B. And then my new C will be 2y minus 3y minus 2z equals minus 8. I'm just substituting this in there, right? Now I can clean these up one more time, and I will get another new b. This one will be 3y plus z equals 9, and this one will be minus y minus 2z equals minus 8. You with me? I like it. And now what we want to do, step 2, whoops. Step 2 is eliminate. We could technically rearrange this one because the y just has a negative coefficient. We could get rid of that. We could multiply everything by -1, and then we could we'd have to rearrange too, wouldn't we? And then substitute. But let's just eliminate. Let's just multiply this one by +2, and then the z's will cancel, right? We could have multiplied this one by 3. It doesn't really matter. But let's just do this. And so I'm going to rewrite b, and that will be 6y plus 2z equals 18. Don't forget that when you're changing these values, do the other side of the equal sign too. Sometimes I would forget. All right, now we're ready to add these two, and we get 5y, goodbye, equals 10. Oh, y equals 10. Well, that was delightful, wasn't it? Now we look back through all of our equations and say, okay, what else can I find out that's simple? My eye goes right back to this one. x equals 2 times y. Y equals 10, so I'm telling you what, x equals 20, right? And now, wait a minute. Oh, what in the world? What in the world? I went crazy. I went off the rails. Sorry. Y equals 2. Sorry. And so now x equals 4, right? Oh my gosh, thank you. You must have been panicking when you saw me do this. You must have been like, she's lost it. She's lost it. Our math teacher has had too much quarantine or too much math. It's hard to tell. And she has flipped her lid. Okay, but I found it, so it's all right. That's the rules in math, you guys. If you find your error, it's fine. Don't worry about it. The 3 of them have to add up to 9. These add up to 6, so I'm going to call z as 3. Oof, I got it right. P.S., just so you know, you don't have to, you can use any of these equations to solve for the other pieces. I look for what seems the easiest, but you could use any of them. And then I'm going to write them as an ordered triple because, you know, extra points for that. I was talking to the Algebra 1/2 kids about To Infinity and Beyond, which I know is a quote from Toy Story, which is a specific quote from Buzz Lightyear, who's Tim Allen. But I always associate, then I start thinking about the little cowboy who's Tom Hanks, but I can't remember the cowboy's name, and it's really bothering me. And I know you would yell it at me, I know you know, and I was explaining to them that my kids were just a little bit too old for the Toy Stories. They were like into middle school when Toy Story came out, so it was kind of like a little kids movie to them. So we didn't watch it all that much. We usually watched it if we had little kids over. But in any case, I'm struggling desperately, and I'm going to have to find out what the name of that frickin' cowboy was, because it's driving me crazy. Okay, one more of these. Use substitution and elimination as necessary. Here we go. Okay, there are our 3 equations. We can call them A, B, and C. John just does that so that we can talk about them easily. All right. This is normal. This is normal. Okay, this, wait a minute. I recognize that this is almost cute, but it's kind of gross the way it looks. So what I'm going to do is I'm going to add 3z to both sides. X equals 3z. Oh, I like that so much better. So I'm going to substitute 3z in for those x's. All right, now this is going to be a little bit messier because I can see there's a coefficient in front of the x. So I'm going to have to multiply this 3z by 2 and this 3z by 3. But I can do that, and I'm going to write that right now. Ready? The first one will be 6z plus 2y minus z equals 12. The second one will be 9z minus y plus 2z equals 21. Okay, now that's better, right? But now I can combine, I can add like terms, right? So 6z minus z is 5z plus 2y equals 12. And then 9z and 2z, that's 11z. 11z's minus y equals 21. Notice that I'm not actually swimming any fish here. I'm just multiplying. I substituted, and then I added like terms, and now I'm going to multiply. I think what's in order is, let's do the bottom row by 2, right? We've already got the plus minus. We'll cancel out the y's. I don't want to multiply. I don't want to deal with these. That's gross. Okay, so I'm going to multiply the bottom one by 2. And that will be 22z minus 2y equals 42. And now I'm going to squiggle that middle line out because it's been replaced. And now I'm adding together top and bottom. I don't want to keep rewriting these infinitely. I try to be strategic, and I encourage you to do the same so that your work isn't driving you nuts. Okay, 27z. The y's cancel, equals 54. I immediately recognize that this is 9 times 6. No, it's 9 times 3, sorry. This is 9 times 6. So that tells me that if I multiply this by 2, that should be the same. So I'm going to divide. Does that make sense? I look for these patterns. 9 times 3, 9 times 6. So that tells me that this number must be half because 3 is half of 6. So 27 must be half of 54. And it is. So z equals 2. Beautiful. Now I can go back in here and figure out my x, because I know that x equals 3z, so x must equal 6. And now I'm going to have to deal with one of these monsters. I'll take the first one. 2 times x, which is 6, plus 2y, minus z is 2, equals 12. So I'm using a, the original a. So this is 12. So I'm going to swim both numbers over to this side. I'm going to subtract the 12, and I'm going to add the 2, right? So that'll cancel those. And I'll get 2y equals, 12 minus 12 is 0, plus 2 is 2. Looks like y equals 1. Unless I'm doing some of that new math like I did in that other problem. Oh yeah, where 10 over 5 was equal to 10. That's pretty good, wasn't it? Okay. But now y is equal to 1, and I can write this as the values, or I can write an ordered triple, 6, 1, and 2. Yay! All right, you guys, feel very smart. That's using both substitution and elimination, and we just let the equations give us hints as to what to do when. All right. We have one more topic in this lesson that is related to polar vectors. That's the sound of your brain throwing on its system of equation brakes and getting ready to talk about polar vectors. Negative vectors. Okay, now we know that polar coordinates take this shape. You're writing all this down, right? I know it was a long time ago, back in September, that I told you I wanted to write I want you to write everything down that I write. And I know that that was a long time ago, and you might be thinking, well, she said it back then, but I don't think she means it anymore. I do. I really do. I really do want you to write down everything I write down. So please keep going. Okay, this is the distance. This is the direction. This measures the angle, and this measures the hypotenuse, right? We can put it in this format too, if that makes it easier to remember, right? And we've talked about negative angles, right? And what I think we agreed, although you had no say in the subject, but negative angles, like let's say it's minus 30 degrees, you just measure in the opposite direction. Instead of going up this way to measure 30 degrees, the minus sign tells you to go down 30 degrees. And so it would look something like that, okay? Those are negative angles. What we're talking about now is negative vectors. What happens if you have a minus sign over here? And just for fun, let's give it a negative angle and a negative vector. Okay, so let's figure out how we would draw this. This tells us to go down 30 degrees. Now, I'm going to put a dotty line in here. Right, let's pretend that's 30 degrees. And this is our distance of 4, right? But what this minus sign tells us is, no, not in the normal direction. Do it in the opposite direction. So what that tells us is we have to flip this line, which we thought was going to be our hypotenuse, we have to reverse it, essentially, right? If you think of it as like driving, instead of putting it in drive to come out from the origin, we're going to put the car in reverse and go backwards. And what's tricky is making sure that you understand how the angle is working with that too. Since this is a 30-degree angle below, this will be a 30-degree angle above. And now we just have a normal hypotenuse of 4. So this minus sign, that's how I think of it. This minus sign tells us to back up the vehicle, put it in reverse. Don't go forward, put it in reverse to measure it. And use the angle to make sure that you get it lined up properly, okay? This is 30 below the line, so I drew in the 30 above the line. And now the negative angle's gone away. That's what we want, okay? All right, we're going to do one problem with these. And then we're done with this lesson. Already, right? Add -4 at -20 degrees and 5 at 135. Okay, well, we get to use our calculators for these, so grab your smartphone or what have you. Smartphone, that is such a like 2008 thing to say. So we do the same thing. We draw the triangles, we find the right and the up values, and then we will combine them. All right, so what I'm going to want my answer to look like is I'm going to have a sign and a number for the right value and a sign and a number for the up value of the first one and then the second one, and then I'm going to add them. Oh, happy days. And I'll get an answer that looks like that. Okay, let's draw a triangle, shall we? -20 degrees tells me it's going to be in the 4th quadrant, but -4 tells me we're going to back up. That's why I did this was an example, so we were preparing for this one. So I know this is going to end up being, I'll just draw the whole thing. I won't try to get too clever on you. Okay, -20, I go down here, and I put this in. This is where it would be if it was a positive vector, but it's not. Instead of going forward, I want to go backwards. Notice I draw that one in solid. This is 20 degrees. This is 4. So our right value is going to be 4 times the cosine of 20 degrees, and our up value is going to be 4 times the sine of 20 degrees. We've done that so many times that I hope it's natural and normal to you. Okay, this one had a negative angle and a negative vector. This one is blessedly positive. And I can quickly see this is going to be 2nd quadrant because it's going to be 90 plus another 45. Hypotenuse of 5. So this one is going to be, the right value will be 5 times the cosine of 45 degrees, and the up value will be 5 times the sine of 45 degrees. If I'm going too fast, if you don't understand what the heck I'm doing here, then you need to holler in the video chat and say, these vectors are killing me, or something akin to that, so that I can stop and help you. At this point, I do expect you to have it down pretty fast. All right, so let's get these values into here. You're running them through your calculator, and we see that this one is, oh, I'm sorry, it's plus 3.76. And this is just a second, I've got to figure out the signs. This is 1.37. Oh, no. Okay, this point is going to be a negative right and a positive up. And this one is also going to be negative for the right and positive for the up. This value is, they're both 3.54. 3.54, that's really hard to see. 3.54. These are both negatives, these are both positives, which makes sense because they both ended up being second quadrant angles, although you never would have known that just to look at them in the first place, right? So our final value is negative 7. Let's see. I rounded slightly differently than John. So that is 0, 12, 7.30, negative 7.30 to the right, and positive, I'm going to add it myself, 4.91 to the up. This is the right answer. Okay? So the trick here was all in dealing with this negative angle, negative vector, car backs up. I hope that makes sense. We've reached the end of lesson 76. I've probably confused you thoroughly, but you know, that's my job. No, just kidding. My job is not to confuse you. My job is to enlighten you. How about that? Do you feel enlightened? I am the Buddha. Okay, no, I need to stop. I need to stop. You know, I would never for $1 million listen to these videos over because I don't want to hear all the ridiculous things I say. Better that they just, you know, float past me and you have to deal with it. I should probably contribute to your future counseling. Okay, I'm done. 76. Goodbye.